Okay, so Pemdas, the thing that you're going to live and die by when it comes to performing operations on a polynomial or anything else of that type. It could be an incredibly long addition string and then an incredible over some string of factors or something like that. It doesn't matter. This is what you're going to be using. It is the most streamlined way to get from a messy problem to a not so messy answer. So, you first start off, let's just set up something here, 2 plus 3 and squared, and then you're going to divide this by 2. Okay, so working from left to right, well, there's multiplication, and then you have your parentheses. That takes precedent over everything else. It's parentheses, like this. That's your first operation, right here, which we have. So we're going to do that first. So we have 5 squared divided by 2 times 5. Now, we still have to work with the stuff that's in the parentheses because exponents come after, as in right here. So 5 times 5 is 25. You're going to divide this by 2, but you're also going to multiply this by 5. Okay. Now, we're going to work from left to right. I'll explain that in a second, but we're going to work from left to right every time. Whether it's incredibly long, incredibly short, 2 numbers, doesn't matter. We're going to work from left to right. So, 5 times 25, 125, divided by 2, 60, so it's equal to 62.5. And that, well, wait real quick, that is your answer, 62.5. Okay. Yes. When you have multiple operations like this, just work from left to right instead of jumping around and doing a ton of other stuff, because you might lose order. But if it works for you, jump around, especially if it's just gonna get you the exact same answer. It doesn't matter. So, now that we kind of worked through that a little bit, we're gonna go on to the explanation for this grouping. It's very simple. One of these operations that are in each curly brace does not take precedent over the other. So if you have multiplication in a line, let's see if x times y and divided by z. You're just going to do this part first. You're going to multiply the x into the y, and then you're going to divide by z, and then you're going to get some answer theta. There, you're going to get some answer theta. It doesn't really matter what way you do it. Well, it doesn't really matter what numbers these are. It matters in the order that you do it. So you can multiply this to this, divide, you get your answer. Same thing with addition and subtraction. You have x plus y minus z equals, again, some answer theta. Because you're going to go from left to right, addition, then subtraction, then you'll have your answer, or you'll have addition, subtraction, multiplication, a series of parentheses, so nested parentheses. Then you maybe have cube root, square root, square. And because, okay, actually now that I've talked about square roots, I'll actually talk about them real quick. Technically, a square root of some number is equal to a half power. So it counts as an exponent, but we denote it as this square root symbol. Just so you would in a equation that you're trying to solve, or in some type of problem you're trying to get the answer to. So you have some number minus some other number, let's say y, and then you are dividing this by z, and then you get some answer theta. You're going to do this operation first, then this operation, and then you're going to subtract the two. Hopefully this is making sense so far. Now I'm going to lay out some problems on the board. I'd like you to solve them real quick. Take a break, solve them, and then I'll run through them with you. So we're kind of on the same page of how things need to be done and how to tackle each problem, especially when it looks incredibly complex. You can just break it down into simple little pieces. I'm going to write those up real quick, and then we'll get going. Okay, so I have one plus 3 minus 5 cubed over 5 8 times 2 we have 2 9 plus 2 times 3 that's 15 26 30 Okay, that should be good for now. Okay, now, move out of the way real quick so you can write these down. We have one, I'm just gonna separate these with parentheses so it's very clear where each one starts and where each one ends. Okay, so these are your 4 problems. Pause, write them down, try and work through them. And then once you're done, start up the video again, and then we will go through each one on their own to, if you have any problems or had any problems when you're going through them, I'll hopefully be able to help you deal with those problems and actually work through the problem and give you a little more confidence when you have to tackle something similar or something completely different, because you're going to know the exact rhythm and everything you need to do in order so you can get the answer that you want or that you need. Okay, so we have 1 plus 3 minus 5 cubed over 5 square root 8 times 2. Okay, this is going to equal some number we don't know yet. It's going to equal, let's just give it a variable so it looks kind of nice. Okay, so let's move on. So as we know, we are really going to be starting with this part here. To make this a little easier to look at, I'm actually going to separate the two. Cubed. And this is actually divided by this. 5 square root of 8 times 2. This, if you want to work with it like this, because it's a little cleaner, it's more obvious what is going on. Okay, we're going to start with this side here. I'm going to go addition first. So that's going to be equal to 4 minus 5, which is going to give you -1. So -1 cubed. And now we're going to work in this parenthesis as well. So divided by, so 8 times 2 is 16. 16, square root of 16 is 4 times 5 is 20. I'm going to go 20 here. And then when you have a cube or any type of exponent that is odd and your given number here is in parentheses, you're basically going to just write it out like this. 1, 1, 1, there. And you're going to multiply each subsequent thing by the last. So, as we know from the last video, negative times a negative, you are multiplying a negative area by a negative area, therefore giving you a positive area. So we now have 1. And that's multiplied again by a negative area, giving you a negative area. It's just easier to think about this as if it is an even power, it is going to be a positive number. If it's a odd power, it's going to be a negative number if it started out as a negative. So, we now know that the answer over here is -1. And divide it by 20. And the same principle that we talked about yesterday is going to apply to today's problem as well, where if you have one number in some operation, and mostly in multiplication and division, it will change the value to a negative. So that's -1 divided by 20, which should give us, as an answer, 0.05. That is your answer to this. Hopefully you got the same answer. If you didn't, that's okay. I helped you work through it. Now we're going to move on to the next one. There we go. Bam. Okay. So we have square root 30 plus 2 times 6 over 3 times 4 minus 7. And if you want to write it similar to the way that I wrote it last time, that's perfectly okay. Whatever helps you solve the problem the easiest, go for it. Do that. Now, moving on to solving this. So, when you have a square root like this, it's really actually treated like this. You have 30. You have some quantity. 2 times 6 to the half power. That's really what you're doing with this. You're having this string here of operations, and you are setting it in parentheses so you know that it all has to be solved first, because it's all under the radical. So, going back through and actually doing all the operations, you have 30 plus, whoops, I didn't write that right. That's my bad. I was gonna say, that's not how I set up initially. Okay, so 2 times 3, because we cannot do addition before multiplication, 2 times 3 is going to equal 6. And 30 plus 6 is equal to 36. And then over 3 times 4 minus 7. So we're going to take this and we're going to simplify it. So it's really just 6. And then we're going to start working on the bottom part. So 3 times 4 is just 12 minus 7, which will get you the answer of 6 over 5. As you can see, that I've set it up so they're going to be perfect squares. Sometimes you might not have a perfect square, and you might be asked to simplify that square or just leave it. A lot of the times you are just going to leave it. It makes the answer a little cool, but it doesn't give you the answer unless you run it through a calculator, especially if it's not a perfect square. Now, hopefully that helped that make a little more sense. On to the next one. Okay. So you have 2 times the quantity 11 minus 22 divided by 7. So, as we did yesterday, we're going to subtract this positive area from this lesser positive area, giving us a difference, and this difference becomes a negative area. So we're going to have negative 11, and then multiplied by 2 divided by 7. So because we're always working left to right, we're going to multiply this 2 into this parentheses here, giving us negative 22. Oops. Divide by 7, which then gives us negative 22 over 7. We're just going to set this as an improper fraction because we're trying to move through it as fast as we can. You can make it a proper fraction. It's going to be negative 3 1/7. It's going to be the proper fraction, but improper fraction for this case is fine. Okay, now it's a nice and fast one. Okay, and finally, we have this last problem, 2 minus 20, the quantity, and multiply by the quantity 3 times 7. So, going from left to right, no matter how many parentheses there are, you're always going to start with the one on the far left. So, again, like yesterday, we're subtracting a positive number greater than the first positive number, making it go past 0 and become negative, or negative area. You have negative 18 is what this is going to equal, because it's 2 minus 20. You're going to put that back in the parentheses. Then you have 7 times 3, which is going to equal 21. And then you multiply these two together to negative 2. Let's put that there. 2, and then 6, 17, and then 8. So 378 there. And that's your answer, I believe. Yep. Yes. Okay. 3 negative 378. Okay. If you still don't feel comfortable with this, that's perfectly fine. Just go to the website that I've linked in the description, go over some problems like this, or just look up a problem set via Google. It's pretty easy to do that. There are a lot of problem sets you can find as like a free PDF download that will take you through just a ton of problems, and they become really long and not terribly complex, just really long, so it's a really tedious process, but it will get you really comfortable with PEMDAS as a whole. Okay, I hope this video was helpful. If not, leave a dislike, tell me it was terrible and I explained this horribly. If it helped, leave a like, tell me how it helped you, and leave any questions you have about something I did. Well, anyway, hope you guys have a great day. Remember, practice makes progress, not perfect.